So good afternoon, class. Welcome to the environmental science lecture. So in our first lecture today, we will be discussing about environmental problems, their causes and sustainability. So mainly we will be discussing why we have environmental problems and then how we can make our transition towards sustainability with an emphasis on what is sustainable development, what are the United Nations Sustainable Development Goals and how we can achieve them. Okay. So first and foremost, whenever we talk about environment, what we need to understand is that environment is virtually everything which is around us. So it is basically the sum total of both living and non-living components influencing the responses in any organism. And the Earth's natural environment mostly consists of four interlinking systems. Now, what are these four interlinking systems? They are the hydrosphere, the lithosphere, the atmosphere, and the biosphere. So the hydrosphere, as we know, is the combined mass of water found on, under, and over the surface of the planet. And then the lithosphere, as you can understand again from the name of it, refers to the mantle of rocks which is constituting the Earth's crust, which is the outermost solid surface of the planet. And then the cover of the gases that envelop the Earth, it is called the atmosphere. And biosphere is basically the global sum of all living organisms, ranging from the tiniest microscopic organisms to the largest whales in the ocean. Now, these four systems, that is the hydrosphere, the lithosphere, the atmosphere, and the biosphere, they are in a constantly changing state, and such changes are mostly affected by human activities and vice versa. So an environmental problem arises whenever there is a change in the quality or quantity of any of these systems which directly or indirectly affect the health and well-being of living organisms in an adverse manner. So some of the environmental problems which are critical at the present time, they are fairly widely known. Why? Because of the growing awareness at every level of society, including government, general public, and the scientific community. So recently, a survey was carried out. In fact, this survey was carried out in 2017 among more than 7,000 men and women from US, China, India, and so on. And they were asked to identify the major environmental problems or the problems which they believe are the most pressing environmental problems today. So according to this survey, the top environmental concern was climate change, air pollution, water scarcity, and water quality. So these four were identified as the topmost environmental concerns, and to a certain extent, depletion of natural resources, food safety, and population growth. These were also identified as other major environmental issues. Now, see, we have been always discussing about environmental issues, isn't it? We talk about climate change, we talk about air pollution, we talk about water scarcity, and so on. But seldom we talk about the problems that are, we seldom talk about the causes that are responsible for these environmental problems. Okay, so what are the causes? So according to various environmental experts, there are actually four major causes of environmental problems we face today. So first and foremost is the population growth. Second is affluence, which is based on wasteful and unsustainable resource use. Then the third one is poverty, and the final one is basically exclusion of harmful environmental cost from the market prices of goods and services. So according to various environmental experts, these four are the topmost reasons why we are having environmental problems in the first place. So in the first part of this lecture one, what we will be doing is we will be revisiting or we will be analyzing in details how each of these factors are causing environmental problems. Okay, but before that, there is something more important that you need to understand, and that is the concept of natural capital. Now, see, humans have evolved, grown, and thrived in nature. Okay, So in fact, nature and everything that it gives us has been the catalyst for where we are today. So its resources have enabled people to dominate the planet, complete with modern expectations, benefits, and luxuries. So starting from the supply of raw materials, water, food, medicine, and energy, to the pollination of crops, formation of soil, and protection from flood, storm, and erosion, the planet's natural system provides a range of vital services that underpin production, trade, livelihoods, and consumption in every country. So the natural assets, okay, so the natural assets that provide these services, okay, that is the ecosystem, species, then waters, river, sea, land, minerals, atmosphere, all these are basically an immensely valuable component of a nation's wealth and a major factor in determining its level of economic prosperity. So we can think of it as a natural capital. So basically what we are trying to say here is that nature is providing us with vital goods and services which is necessary to sustain modern human society. Okay. So these goods and services that is provided by nature at free of cost, we call it as natural capital. And to sustain or to progress modern human society, we will continue to need the resources that nature is providing us or nature has provided us throughout history and has actually allowed us to thrive. Okay, so now let's say in economics, what we understand that capital is money and other forms of wealth that can be used to support one's lifestyle. So it can provide a sustainable income if we use properly, and of course, it can also support an economy. Now, what is natural capital? So natural capital is basically the sum total of the natural resources and natural services that keep us and other forms of life alive and support our economies. So basically, natural resources are materials and energy in nature that are essential or useful to humans. So these resources, they are often classified as renewable resources, for example, air, water, soil, plants, and wind, or we can also classify them as non-renewable resources such as copper, oil, and coal. Now, natural services, on the other hand, they are basically the processes in nature, such as purification of air and water, which support life and human economies. So the Earth's biodiversity of species, ecosystems, and interacting components, they provide us with these essential services at no cost. So we can use technology to enhance such services, but there are no substitutes for them. So natural capital is basically supported by energy from the sun. So if you take away solar energy and natural capital and the life it supports, it would definitely collapse. So solar energy, what it does, it is warming the planet and supports photosynthesis, which is a complex chemical process that plants are using to provide food for themselves as well as for us and most other animals. So this direct input of solar energy also produces indirect forms of solar energy such as wind, flowing water, and biofuels made from plants and animal residues and so on. So therefore, our lives and economies always depend on energy from the sun and natural resources and natural services, which we call the natural capital provided by the earth. Now, with financial capital, when we spend too much, what will happen? We will run up a debt, which if left unchecked, it can eventually result in bankruptcy. Okay. But similarly, with natural capital, when we draw down too much stock from our natural environment, we will also run up a debt which needs to be paid back. So if the stock of natural resources is at risk, then our organizations are at risk. And ultimately, the planet and our human well-being is also at risk. So, poorly managed natural capital becomes not only an ecological liability, but also a social and economic liability too. Okay. Now let's now revisit or let's now understand how each of the causes that I showed to you at the beginning of today's lecture are responsible for creating environmental problems. But to understand each of how these factors are contributing to environmental problems, you need to always keep in mind this concept of natural capital. Okay. So exponential growth, as you all know, occurs when a quantity such as the human population or pollution increases at a fixed percentage per unit of time. Let's say 2% per year or 5% per year and so on. The thing or the essence of exponential growth is that it starts off slowly, but after a few doublings, what it happens, it starts to grow to enormous number because each doubling is twice the total of all earlier growth. Okay. So now so because of exponential growth in the human population, okay, in 2009, there were about 6.8 billion people on the planet. So what happened was collectively these people, they consumed vast amounts of food, water, raw materials and energy. And in the process, they produced huge amounts of pollution and waste. Now, unless death rates rise sharply, there will probably be 9.6 billion of us by 2050. So this projected addition of 2.5 billion more people within our lifetime is equivalent to about 8 times the current US population and more than twice that of China, okay, which is currently the world's populous nation. So the exponential rate of population growth, okay, it has actually declined to some extent since 1963, but even after that, okay, but even after that, each day we are adding an average of around 300,000 more people on the earth. So this is basically almost amounting to adding a new US city of Los Angeles, California almost every 2 months, or a new France every 9 months, or let's say a new United States, which is currently the world's third most populous country, about every 4 years. Now, the thing is, no one knows how many people the earth can support indefinitely and at what level of resource consumption or affluence without seriously degrading the ability of the planet to support us and other forms of life and our economies. Okay. See, every day the planet must support more and more people. And at the same time, their expectations for comfort and better lives are rising. So both trends are leading to a growing global demand for resources and services from nature, including food, carbon sequestration, fiber, wood, and so on. So human demand on our planet's resources, however, already exceeds what the earth can renew. So we can continue depleting natural capital as long as the stocks last. But that is a path that undermines our current and future economic possibilities. Okay, so overpopulation is impacting all the various dimensions of sustainable development. See, when we are overpopulation is resulting in overuse of non-renewable resources. Okay, it is putting pressure on land and soil degradation. Then it is also straining infrastructure. It is resulting in widespread poverty and unemployment, inequitable distribution, and so on. It is resulting in lack of education to large population, social unrest, poor coverage of healthcare, and so on. Okay. So from a human standpoint, a resource is anything which is obtained from the environment to meet our needs and wants. Now, some resources are renewable while others are not. So a renewable resource, it can be replenished in days to several hundred years through natural processes as long as it is not used up faster than it is renewed. So examples mostly include forest, grasslands, fish populations, fresh water, fresh air, fertile soil, and so on. So the highest rate at which a renewable resource can be used indefinitely without reducing its available supply is called its sustainable yield. So when use of a renewable resource exceeds its natural replacement rate, then the available supply begins to shrink, a process which we call as environmental degradation. So some renewable resources can be used by almost anyone. So examples are like fresh air, underground water supplies, the climate's earth, and the open ocean and its fish, and so on. Okay, so this brings to the next concept that is called the tragedy of the commons. So basically what we are doing, we are environmentally degrading many openly shared renewable resources. So in 1968, biologist Garrett Hampton, he called such degradation the tragedy of the commons. Now, what is this tragedy of the commons? So tragedy of the commons occurs because each user of a shared common resource or open access resource reasons that if I do not use this resource, someone else will. So the little bit that I use or pollute is not enough to matter, and anyway, it is a renewable resource. Okay, so see, this logic will work when the number of users is small. Okay, but whenever the cumulative, but eventually what will happen, the cumulative of many people trying to exploit a shared renewable resource can exhaust or ruin it. Okay, so then no one can actually benefit from it, and that is what we call as the tragedy. Okay, so for example, see, nobody really owns the groundwater. So the groundwater is always available up for grabs. So, but too much pumping of groundwater can result in the exhaustion of the resource. So eventually depletion by a few means depletion for all. So that is basically the tragedy. Now, there are two major ways to deal with this difficult problem. So first and foremost, what we can do, we can use shared renewable resources at rates well below their estimated sustainable yields by reducing use of the resources, regulating access to the resources, or doing both. So for example, see, governments can establish laws and regulations limiting the annual harvest of various types of ocean fish that are being harvested at unsustainable levels. Okay, so that is something that can be done. Next, what we can do is like we can convert open access renewable resources to private ownership. Now, in the second solution, the reasoning is that if you are owning something, you are more likely to protect your investment. Now, that sounds good, but the problem is this, it is not practical for global access resources such as the atmosphere and the open ocean, because we cannot divide and sell the atmosphere or the open ocean as private property. Okay, so that is the problem. So the best solution will be to share renewable resources at rates, use shared renewable resources at rates well below their estimated sustainable yield. Okay, now coming back, renewable resources, non-renewable resources on the other hand, we know they exist in a fixed quantity or stock in the Earth's crust. So on a time scale of millions to billions of years, geological processes can actually renew such resources. Okay, but on the much shorter human time scale, these resources can be depleted much faster than they are actually formed. So such exhaustible resources mostly include energy resources such as coal and oil, metallic mineral resources such as copper and aluminium, non-metallic mineral resources such as salt and sand, and so on. So as non-renewable resources are depleted, human ingenuity can also often find substitutes. Say for example, during this century, a mix of non-renewable energy resources such as wind, the sun, flowing water, the heat in the Earth's interior, all this could reduce our dependence on non-renewable fossil fuels such as oil, coal, and natural gas. Also, various types of plastics and other synthetic materials, it can also replace certain non-renewable metals. But sometimes there is no acceptable or affordable substitute. So the underlying message is that, see, we are dependent on a fair share of renewable and non-renewable resources to sustain our human society. And all these resources are limited. Okay, so therefore it really matters if all these resources are used at an unsustainable level or in an unsustainable manner by our increasing human population. Okay. Supplying people with renewable resources and producing the resulting wastes and pollution can actually have a large environmental impact. So we can think of it as an ecological footprint. So ecological footprint is basically the amount of biologically productive land and water which is needed to indefinitely supply the people in a particular country or area with renewable resources, okay, such as fruits and vegetables, fish, wood, fibers, and so on, and to absorb and recycle the wastes and pollution produced by such resource use. So in other words, ecological footprint measures the demand on and supply of nature. Okay. So on the demand side, the ecological footprint, it measures the ecological assets that a given population requires to produce the natural resources it consumes. Okay. So human society is actually built on what is provided by nature. So no value chain is possible without input from it. So with every breath we take, we depend on the quality of the air, the purity of the water, and the richness of the biodiversity around us. So nature and its resources, all these are an integral part of our social and economic systems. Okay. And research increasingly shows that nature's vital importance to our health, well-being, food, and security. So the welfare of human society is highly dependent on all these resources. So the ecological footprint actually accounts or helps us to quantify the size of our dependence. So the ecological footprint, to keep it simple, it actually tracks the use of 6 categories of productive surface area. That is the cropland, the grazing land, the fishing ground, built up land, okay, forest area, and carbon demand on land. So when we talk about the grazing land footprint, it basically measures the demand for grazing land to raise livestock for meat, dairy, leather, and wool products. Okay. So when we are talking about forest product footprint, what it does, it measures the demand for forests to provide fuel wood, pulp, and timber products. Then for when we are talking about forest product footprint, it measures the demand for forests to provide fuel wood, pulp, and timber products. Then when we are talking about fishing grounds, fishing ground, it actually measures the demand for marine and inland water ecosystems, which is needed to restock the harvested seafood and support aquaculture. And then cropland. So the cropland footprint, it actually measures the demand for land for food and fiber, feed for livestock, oil crops, and rubber. And then we have the built up land. So the built up land will be representing the amount of land which is covered by human infrastructure, which includes roads, which includes housing, which includes industrial structures, reservoirs for hydropower, and so on. And finally, the most important one, we have the carbon footprint. So the carbon footprint, it measures the carbon emission from fossil fuel burning and cement production. So these emissions are basically converted into forest areas needed to sequester the emissions not absorbed by oceans. So it accounts for forests varying rates of carbon sequestration depending on the degree of human management. Then the type and age of forest, emission from forest wildfires, and soil built-up and loss. Okay. So these are the 6 components that the ecological footprint takes into account. Okay, and to quantify the size of our dependence on natural capital. Okay. Now, this ecological footprint, in order to understand the ecological footprint, we need to understand that these next 2 concepts, which is called the biocapacity and bioproductivity. So now what is biocapacity? So biocapacity is basically the productive area that can renew and provide resources. Okay. So it is basically the amount and rate of production which occur in a given ecosystem over a given time period. So it quantifies the nature's capacity to produce renewable resources, provide land for built up areas, and provide waste absorption services such as carbon uptake. Okay. Now, bioproductivity, on the other hand, is basically the amount and rate at which rate of production which occur in a given ecosystem over a given time period. So the biocapacity acts as an ecological benchmark against which the ecological footprint can be compared. So biocapacity is basically area times the bioproductivity, and it is basically, it quantifies and it acts as an ecological benchmark against which the ecological footprint can actually be compared. So the ecological footprint, it does not directly include water use, but it is intrinsic to biocapacity, because lack of water or polluted water has a direct impact on the availability and state of biocapacity. So both the ecological footprint and biocapacity, they are expressed in a common unit which we call as the global hectare. So the global hectare is basically, one global hectare basically represents a biologically productive hectare with world average productivity. Okay. So the planet's biocapacity is currently now about 30% higher than what it was in 1961, largely due to agricultural practices. Okay. Now, this expansion, however, may not last given climate change, water scarcity, energy availability, topsoil erosion, biodiversity loss, and so on. So, as we are phasing out fossil fuel as anticipated in most imaginable climate mitigation scenarios, biocapacity will not only have to feed us, but it will also have to help us replace fossil fuel together with wind and solar power, high-tech energy like nuclear and possibly nuclear fusion in the distant future. Okay, so biocapacity is basically measuring the supply side, that is area times the bioproductivity, while ecological footprint, which is the demand, is basically the product of population, consumption per person into the product of population, consumption per person, and the footprint intensity. Okay, so when we are trying to calculate the ecological footprint, so the biocapacity helps us to quantify the nature's capacity to produce renewable resources, provide land for built up areas, and provide waste absorption services such as carbon uptake. Okay. Now next comes the fact is the ecological deficit. So whenever a country or a region, or let's say the world as a whole, its total ecological footprint is larger than its biological capacity to replenish its renewable resources and absorb the resulting wastes and pollution, it is said to have an ecological deficit. Okay. So a region in ecological deficit, it meets demand by importing, liquidating its own ecological assets, such as overfishing or emitting more carbon dioxide into the atmosphere. Okay. But on the other hand, if a region's biocapacity exceeds its ecological footprint, it has an ecological reserve. Okay, so ecological, whenever the ecological footprint is greater than the biocapacity, we call it as an ecological deficit. While whenever the ecological footprint is less than biocapacity, we call it as an ecological reserve. Okay. So in 2008, the World Wildlife Fund and the Global Footprint Network, they estimated that humanity's global ecological footprint exceeded the Earth's ecological capacity to indefinitely support humans and other forms of life by at least 30%. Okay, so that figure was actually about 88% in high income countries such as the United States. So in other words, humanity needed the equivalent of about 1.3 Earths to indefinitely supply the current average use of renewable resources per person and to dispose of the resulting pollution and waste. So if the number of people and the average use of renewable resources per person continue growing as projected, then by around 2035, supplying such resources indefinitely will require the equivalent of two planet Earths. Okay, so today humanity is using the equivalent of 1.6 Earths to provide the resources we use and absorb our waste. So this, what does this mean? It means that it now takes the Earth 1 year and 8 months to regenerate what we use in a year. So we use more ecological resources and services than nature can regenerate through overfishing, overharvesting forests, and emitting more carbon dioxide into the atmosphere than forests can sequester. Okay. So for more than 40 years, humanity's demand on nature has actually exceeded what our planet can actually replenish. So carbon has actually been the dominant component of humanity's ecological footprint for more than half a century. And for most years, it has been on an upward trend. So in 1961, carbon was 36% of our total footprint, but by 2010, it comprised 53%. Now, the primary cause has been the burning of fossil fuels, that is coal, oil, and natural gas. And as you can see in this graph clearly that with the 2008 economic crash, so the lockdowns of 2020 due to COVID-19 has also reduced humanity's demand by nearly 10%. Okay. But then you need to understand one thing, that this reduction was not caused by any structural or infrastructural change. So the gains are unlikely to last. Okay. When we rank countries by total and per capita ecological footprint, it produces very different results. So the ecological footprint of actually the two top five countries, it makes up about half the global total. So analysis of the 2014 national footprint account, it reveals that just two countries generated 31% of the world's total carbon footprint. So these two countries were the US and the China. Okay. So China is basically ranked 76th in its per capita footprint. Okay. So when we are talking about per capita footprint, China ranks 76th in the world. Okay, but with the world's biggest national population, it has the planet's largest total footprint. So the population of the USA is again quartered to that of China. Okay, but its total footprint is almost as large because of its greater per capita consumption. Similarly, when we are multiplying population with per capita demand, then India shifts from 136th largest footprint per capita to the third largest in total. Similarly, Brazil from 53rd to 4th and Russia from 42nd to 5th. So now you can understand, see, for most of the countries except the United States, how a huge population results in a very high ecological footprint. Although their per capita footprint is significantly low compared to the US. Now in US, the per capita, the total ecological footprint is so high because of the fact is that in the US, the although the population is low, their per capita consumption or their per capita ecological footprint is significantly high. Okay. Next comes to the fact is the Earth Overshoot Day. Okay. But before we proceed, I'll just take a quick break of maybe just I'll take a quick break of 5 minutes and we will just continue. Okay. Okay, so next what we will be discussing is the Earth Overshoot Day. So the Earth Overshoot Day is basically the date when humanity's demand for ecological resources and services in a given year exceeds what the Earth can regenerate in that year. Okay, so it is basically the date in a calendar year when humanity's demand for ecological resources and services in that year exceeds what the Earth can regenerate in that particular year. So how we compute that? We compute it by dividing the planet's biocapacity by with the humanity's ecological footprint, and then multiply it with the number of days in a year, that is 365. So why we are multiplying the biocapacity, dividing the biocapacity with footprint? Because biocapacity, as I said to you, it is the amount of ecological resources which the earth is able to generate that year. So basically it is the demand. Okay, and then the ecological footprint is the biocapacity is basically the supply, the amount of ecological resources which the earth is able to generate in one particular year. So the biocapacity is basically the supply, while footprint, which is the humanity's demand for that year. Okay, so we basically are dividing the supply with the demand and then multiplying it with the number of days in a year to calculate the Earth Overshoot Day. Okay, so according to the Global Footprint Network, which has actually developed this measure, okay, together with the New Economics Foundation. So the first Earth Overshoot Day, it fell on 23rd of December 1970. So it was the first time in human history when the humanity's demand on nature exceeded its biocapacity. Okay, and over the years, rapidly rising population numbers and then rates of material and energy consumption, along with the accelerating erosion of ecosystems everywhere, all this has resulted in the decline of the planet's annual bioproductivity and a reduction in ecosystem functions each year. So therefore, the day on which we overstep the limits of is occurring earlier and earlier. Okay, so basically with rapidly rising population, what has happened, the rate of material and energy consumption along with accelerating erosion of ecosystems everywhere, all this have resulted in the decline of the planet's annual bioproductivity and a reduction in ecosystem services or ecosystem functions each year. So because of which we are overstepping the limits of Earth's annual productivity every year earlier and earlier. So by 1995, the Earth Overshoot Day was on 10th of October. And in 2005, we reached overshoot by 3rd of September. In 2015, we reached it on 13th of August. And in 2019, on July 29th, which was the earliest ever. Okay. But in 2020, the Earth Overshoot Day was reached on August 22nd. So it was basically more than 3 weeks later than in 2019. So this late arrival was of course due to the pandemic, as the world was mostly under lockdown due to the pandemic. Okay, so that halted commercial activities around the world. In fact, the novel coronavirus outbreak, it has caused humanity's ecological footprint to fall by 9.3% in 20 so in so basically in so this outbreak has caused humanity's ecological footprint to drop by 9.3% in 2020 compared to 2019. So the main driver for the reduction were carbon footprint, which reduced by 14.5% from 2019, and forest product footprint, which reduced by 8.4% from 2019. Okay, while the food footprint, it remained unchanged. But this is something not to be celebrated, because this achievement of pushing the Earth Overshoot Day to a later date in the year was not done by design but by a disaster. Okay. So see, fossil fuel, we all know, is by far the dominant source of commercial energy, whose use has also been strongly affected by the lockdowns in many countries around the world. Okay, so the proliferation of lockdowns So the proliferation of lockdowns and so on. Just give me a minute. Okay, so fossil fuel is basically the dominant source of commercial energy whose use has also been strongly affected by the lockdowns in many countries around the world. Okay, so the proliferation of lockdowns and associated public health measures have actually affected almost every sector of the global economy. Say to, for example, so to determine the COVID-19 carbon adjustment, what we did, we divided the pre-overshoot day period into three segments. One was the January-March period, okay, during which the lockdowns were implemented in varying degrees and at different times. Then was the April-May period, which represented the most severe periods of lockdown, and the period from June until the Earth overshoot day, when we saw a gradual loosening of confinement policies. So data from the International Energy Agency for the first 3 months of 2020, it showed that a 3.8% drop in energy consumption was associated with a 5% drop in emission. Then similarly, combining an understanding of the effect of different forms of lockdown on energy consumption and the distribution of lockdown, it also helped us to develop an estimate of the decline in energy consumption by 9.5%. Okay. Then when we analyze the forest products, so the demand for forest products make up a significant part of humanity's ecological footprint. And this demand has been directly affected by the pandemic. So currently forest products, it makes up 10% of the ecological footprint. So two opposing effects appear to influence this demand. So activity in the logging industry has actually declined in recent months, both because of the general reduction in economic activity observed during lockdowns and because of projections indicating diminished demand for construction materials during the coming economic downturn. Now, on the other hand, countries with limited social safety nets, they saw migration from urban to rural areas during economic downturns. Economic downturns. So people who lost in work in the cities, they often return to communities located in rural areas with a significant forest interface, therefore accelerating the deforestation through increased pressure from local agriculture and resource extraction. So the pandemic has actually um, additionally restricted conservation efforts and reduced conservation policing in at risk areas. So this year, so basically the 2020, so the Earth Overshoot Day of 2020, it provides an unprecedented opportunity to reflect on the future we want. So efforts to respond to COVID-19 has actually demonstrated, okay, that shifting ecological resource consumption trends in a short time frame is possible. And as we emerge out of the public health crisis and focus on rebuilding our economies and our lives, strategies informed by biological resource security and one planet prosperity are far more likely to bring about the positive outcomes that decision makers see. So already powerful lessons can actually be drawn from the collective experience of the pandemic. So first and foremost, what we have learned is that governments are capable of acting swiftly, both in terms of regulation and spending, when they put human lives above all else. Seen every country has invested huge amounts of money on healthcare infrastructure and so on, because they put human lives on as the top priority. And we also have seen that humanity is one biology and is stronger when we act together. Okay, so businesses and individuals alike can actually effectively align and collaborate in the pursuit of a shared goal when people recognize that their own lives and that of the people they love may be at risk. So the necessary actions required to protect oneself, one's household, and one's community also protect others. So one's decision at all levels have actually consequences for all. So by now, basically what we have understood or what we have witnessed is that what is possible when humanity comes together to pursue a shared outcome. And what shared outcome can we say it could be more important than our long-term success on our finite planet? Okay. So basically, our past does not necessarily determine our future, but our current choices do. So through wise forward-looking decisions, what we can do, we can turn around natural resource consumption trends while improving the quality of life for all people. So while our planet is finite, human possibilities are not. So the transformation to a sustainable carbon neutral world will succeed only if we apply humanity's greatest strength, which is foresight, innovation, and care for each other. Now, the good news is that this transformation is not only technologically possible, it is also economically beneficial and our best chance for a prosperous future. So, in fact, facilitating this transformation is the best strategy for the long-term success of any organization, including and especially businesses. So there are five key areas that we need to or that can define our long-term trends most forcefully. So all of them are basically shaped by our individual and collective choices. So the first one is how we help nature thrive. See, humanity's quality of life is dependent on the health of our planet's biological resources, including fertile soil, clean water, and clean air necessary for humanity to thrive. Then the second one is how we design and manage cities. Okay, so 80% of the world population is expected to live in cities by 2050. So city planning and urban development strategies, these are instrumental to balancing the supply of natural capital and population's demand. Then the third one is how we power ourselves. Okay. So decarbonizing the economy is our best possible chance to address climate change, and it would improve the balance between our ecological footprint and the planet's renewable natural resources. Then fourth one is how we produce, distribute, and consume food. So basically, how we meet one of our most basic needs, that is food, is a very powerful way to influence sustainability. So sourcing food locally and avoiding highly processed foods can also lower the ecological footprint. And then fifth one is basically how many of us there are. So being committed to everyone living secure lives in a world of finite resources requires addressing population growth. So empowering women is essential for global sustainability. Okay. Next, which will be discussing about overconsumption. So in the early 1970s, there were two scientists, Paul Ehrlich and John Holdren, who developed a simple model showing how population size, that is capital P, affluence or resource consumption per person, which is the capital A, and the beneficial and harmful environmental effects of technology, that is capital T, help to determine the environmental impact I of human activities. So this we can be summarized by the simple equation, that is I is equal to product of P, A and T. So this we call the IPAT, environmental impact model. Okay, so over here P is again at the I is the total human impact on the environment, P is the population, A is the goods and services per person, while T is the impact of goods and services. So so basically, let's say for example, when we want to understand what are the factors that influence the amount of gasoline we burn in automobiles, so how we can calculate it? We can calculate by number of cars, which is our P in this case, then service provided by the car, which is by basically the miles driven by the car, that is our A, and then gasoline per mile, which is the technology. So if we take a product of this, which will give us the amount of gasoline we burn in automobiles, from which we can calculate the amount of CO2 which we are emitting into the environment. Okay. Now let us see how the relative importance of these three factors in developing and developed countries. So see, while the ecological footprint model, it emphasizes the use of renewable resources, Now this model, what it does, it includes the per capita use of both renewable and non-renewable resources. So in most developing countries, the key factor in total environmental impact are population size and the degradation of renewable resources. Why? Because a growing number of poor people in developing countries, they struggle to stay alive. So in such countries, the per capita resource use is low. In contrast, in developed countries, high rates of per capita resource use and the resulting high level of pollution and resource depletion and degradation per person, they are basically the key factors determining overall environmental impact. So some forms of technology such as polluting factories, coal burning power plants, gas guzzling motor vehicles, all these, they increase environmental impact by raising the T factor in the equation. Okay, but other technologies, they can reduce environmental impact by decreasing the T factor. So examples are mostly pollution control and prevention technologies, wind turbines, solar cells that generate electricity, fuel efficient cars, and so on. So in other words, some forms of technology are environmentally harmful and some are environmentally beneficial. Okay, say for example, um, so what we need to do basically is like we need to go for more green technologies to reduce the I. Because in developed countries it is very difficult to reduce the consumption per person, while in developing countries bringing about a sharp drop in population is again a challenging task. So we need to have a balance of both. Okay. So see, in the US, especially when we talk about, so the population of the US is almost one-fourth that of China. But an average American consumes about 30 times as much as the average citizen of India consumes, and 100 times as much as the average person in the world's poorest country consumes. So as a result, the average environmental impact or ecological footprint per person in the United States is much larger than the average impact per person in developing countries. Okay. So some analysts, they say that shop until they drop affluent consumers in the United States and elsewhere, they are afflicted with a social virus called affluenza. Okay. Now, on the other hand, affluence can allow for better education, which can lead people to become more concerned about environmental quality. So it also provides money for developing technologies to reduce pollution, environmental degradation, and resource waste. In the United States and most other affluent countries, see, the air is cleaner, drinking water is more pure, and most rivers and lakes, they are clean than that they were in the 1970s. And in addition, the food supply is larger and generally safer. So the incidence of life-threatening infectious diseases has been greatly reduced. Lifespans are longer, and some endangered species, they are being rescued from premature extinction. So these improvements in environmental quality were actually achieved because of greatly increased scientific research and technological advances, which is financed by affluence. Okay. And education has also spurred many citizens to insist that businesses and governments work toward improving environmental quality. But on the downside to wealth is that it allows the affluent to obtain the resources they need from almost anywhere in the world without seeing the harmful environmental impacts of their high consumption, high waste lifestyles. Okay, so basically what you need to understand is that, see, the P and A, these are basically the cause of the problem, and these two are really difficult to reduce. So to reduce to lower the consumption in developing countries is very difficult, because lowering consumption means to lower the to change the lifestyle of people. And num P, which is the lowering the consumers, that is also we cannot sharply reduce the population overnight. But what we can do, we can go for more green technologies. Okay, so we can go for more clean technologies and so on. So we can improve the T factor in this IPAT model, which can then which can then help us overcome the or reduce the total I. Okay, so since today is the first lecture, so I'll stop here today. Okay, I'll not continue any further. Now, if you have any, so next class, what we will be doing, we will be again meeting next Wednesday. So next Wednesday, uh, I'll be talking about poverty, and then I'll be moving on to discuss about poverty, and then I'll be moving on to discuss about the exclusion of environmental cost from products and markets, and then we will be discussing about the sustainable development and so on. Okay, so that we will be discussing in the next class. And for this course, the grading policy mostly will be, we will be only having two tests. Okay, so there will be maybe one or two assignments. I haven't decided, but the two tests that you will be having, one test I'll let you know when the institute has actually scheduled. So that will be the main thing when we will be having the first test, and then we will have the second test according to the institute calendar. Okay, so if you have any question, let me know. Okay, so if you don't have any questions, so let's end here today. So we will stop here today. So next class.